Hello, and welcome to the Machine Learning Engineer Nanodegree program. I'm Louis Serrano.
I'm Arpan Chakraborty.
And we are the program's lead instructors. Machine learning is becoming indispensable to companies across all industries, and new applications are being devised every day. You may have heard about how Netflix recommends movies based on your tastes, or how Facebook is using machine learning to automatically tag faces in pictures.
But machine learning is not just relevant in consumer applications. It's also changing how large enterprises operate. Google is using predictive modeling to reduce their data center operating costs, and PayPal is using deep neural networks to detect fraudulent transactions.
Accordingly, machine learning engineers are consistently some of the most in-demand jobs, particularly in the tech world. The goal of this program is to help you develop all the skills you need to start or advance your career as a machine learning engineer.
Not only will you learn the concepts of machine learning in detail, but you'll also graduate with a portfolio of real-world projects, where you'll use machine learning algorithms to analyze real data. Udacity's network of subject matter experts will review your projects and give you invaluable feedback to support mastery of these new skill sets.
This program has been built for students with some math and coding knowledge. If you're comfortable with derivatives and matrices, and you can do some coding in Python, Java, C, or any language, you're ready to start. In this program, you'll learn what a machine learning model is, and what are the main algorithms of supervised and unsupervised learning. You'll learn how to train and test algorithms and how to evaluate and validate them. You'll get a solid knowledge of the main algorithms of supervised machine learning, including linear and logistic regression, decision trees, support vector machines, and neural networks. Also, you'll learn the main algorithms of unsupervised learning, including clustering and dimensionality reduction.
And then we'll dig deep into two topics: deep learning and reinforcement learning. In deep learning, you'll learn deep neural networks and convolutional neural networks, used primarily for image recognition. Then you'll learn reinforcement learning, where you'll train agents to carry out optimal actions, starting with Markov decision processes and classic reinforcement learning algorithms, progressing to cutting-edge deep reinforcement learning. And at the end, you'll be able to apply all you've learned to a problem and data set of your choice in your capstone project. Now, don't worry if that sounds daunting. You'll get feedback from our network of expert reviewers along the way to guide you and help you make your capstone project a reality.
When you complete this program, you'll graduate ready to get a job as a machine learning engineer or to continue your journey in the world of machine learning. Cheers! This program is built around projects. When you complete each project, you'll submit it to one of our expert reviewers who will give you personalized feedback. These projects will help you gain valuable experience and build a portfolio that you can share with potential employers.
The first project is available at the start of the program. In this project, you'll use pandas and NumPy to analyze a real data set of passengers on the Titanic. And based on this information, you'll be able to predict their survival.
To heighten your understanding on training and testing machine learning models, you will use scikit-learn and regression to analyze a real data set of housing prices in Boston. You'll build and optimize a model to predict prices of housing.
In the supervised learning project, your task will be to build a classification model to identify the best potential donors for a charity. You'll be able to use several classification algorithms and optimize them for quality.
In the unsupervised learning project, you will study a real data set of customers of a company, and you'll apply several unsupervised learning techniques in order to extract valuable information from this data.
After you gain expertise on the core algorithms of machine learning, you'll be working on projects to strengthen your understanding of deep and reinforcement learning.
The deep learning project will have you build a convolutional neural network to recognize dog breeds from images. Furthermore, if an image of a human is provided, the algorithm will guess which breed of dog looks the most like that human. You'll also be able to improve your results significantly by using pre-trained networks.
You'll then use deep reinforcement learning to design a simulated quadcopter that learns to take off, hover, and land all by itself. As a bonus, you will be able to integrate these behaviors into a single end-to-end system that can autonomously fly from point A to point B.
Finally, in your capstone project, you'll be able to distinguish yourself by building a machine learning project to solve a problem that you are passionate about using any data set of your choice. Our network of expert reviewers will guide you through your proposal phase and will give you solid feedback on your model, your data, and your procedure.
With these projects under your wings, you'll have both the skills and the portfolio to become a successful machine learning engineer. We can't wait to see your contribution to the advancement of technology through machine learning.
In the first part of this program, we'll cover the main algorithms of supervised and unsupervised learning, as well as the main techniques for making your models work well.
In the first section, called Model Evaluation and Validation, you will learn what machine learning models are and how to train them, test them, and validate them. You will learn the main problems one has to deal with when training a model, such as overfitting and underfitting, and you'll be able to measure them and improve your training.
Most algorithms of machine learning fall into two categories: supervised learning and unsupervised learning. Supervised learning is comprised of all the algorithms which will predict a label. We'll go deep into the algorithms of supervised learning, such as decision trees, logistic regression, support vector machines, naive Bayes, and neural networks.
In the next section, you'll be learning the main unsupervised learning algorithms, especially those involving clustering and dimensionality reduction. These are useful when our data comes with no labels and we need to find properties about it. You'll be able to apply these algorithms on real data sets as well.
In the second part of this Nanodegree program, you will go much deeper into cutting-edge topics in machine learning, such as deep learning and reinforcement learning. Neural networks have been crucial in most of the recent advances in machine learning, including AlphaGo, IBM Watson, and self-driving cars. In the next section, you'll get a solid foundation of deep neural networks. You'll also learn convolutional neural networks used for many applications, but in particular for image recognition.
Reinforcement learning is an interesting form of machine learning, where you train an intelligent agent to perform actions in an environment instead of predicting labels or values. You'll get to use state-of-the-art platforms like OpenAI Gym and cutting-edge deep reinforcement learning algorithms like deep Q networks to solve challenging problems.
After completing this program, you'll have a solid foundation in the main algorithms used in machine learning today.
See you in class.